In this video, we're going to use the built-in mathematic functions in Python and learn what's already built in and how we utilize and maximize those functions. So the first thing you need to know is that there is a math library filled with built-in functions in Python that we can use, which is really great. It saves us from having to, strategically trying to figure out how to do a power or how to do a square root or something in Python. So what you can do here is you can actually import in math. So this is similar to when we imported in the graphics, but now we're going to import in math. So if you want to import in any of the built-in math functions, you must type the beginning piece of code at the top of your program. So if you want to import any of these functions that you're about to see, this needs to be the first line in your program. Without that line, Python will not automatically import the math functions library and you won't be able to access them. So make sure that this comes first. So over here on the left-hand side, what you're going to see is math code. And that math code is what you're going to write, or an example of what you might write into Python. And what we're going to do is we're going to talk through what this actually looks like if we import the math functions in and we use these functions. Now, what you need to note is that the only parts of these functions that can change is the numbers on the inside of the parentheses. So this part right here where it says math.pow, essentially in order to use this particular function, which we'll talk about what it does in a second, you need to type math to cite that you need to get this from the math library. So this is why you import math into your program. And then by writing math dot, that's saying program, go into the math library, hence the word math, and you're going to access the pow function that is built into the math library. So make sure that anything with math dot has math dot in front of it, because in order to utilize this function, you need to have the math library and access it using math dot. Now, this math.pow function, hopefully you're thinking, that sounds a lot like a power. That's exactly what this function is. It's the power function. Now, the order in which the two numbers are entered is important. This particular one is going to take 2 to the power of 3. So here, your first number is going to be the base of your exponent, and then the second number is your exponent. So if you were to type the following into Python, math.pow 2, 3, that would take 2 to the power of 3, and it would output 8, and then you'd utilize 8 in your program. Now, if we look at the next one here, hopefully you're noticing that this looks a lot kind of like square root, because that's exactly what this next function is. So this is the square root function. And so you have math.sqrt, and essentially what this will do is it will take the square root of whatever number you put on the inside. So if we put 64 on the inside, it will take the square root of 64, which becomes 8, and utilize that in our program. Now, this next function is really just a built-in number that we often want to use. So when we're working with things like circles and we have to use the number pi, we want to make that as exact as possible. While 3.14 is fine, we really should be using pi when we can, because that's going to take it out to more decimals and be more exact. So here we have math.pi, pi, and this is going to represent the pi function and bring in a very exact version of that pi function so that we don't have to round at all. Now notice here that there's no parentheses, it's just math.pi, and this will allow you to use pi in its exact number form in Python. So you should be utilizing this anytime that you need to utilize pi in your program. Then from here, math.ceil, hopefully you're thinking, well, that kind of sounds like ceiling. That's exactly what this is. This is called the ceiling function. And essentially what the ceiling function does is, just like a ceiling is above you, this ceiling function always rounds a number up. So there will be times when maybe you need to get a result and then you need to round that number up. You want to know what integer is directly above your answer. When that happens, when you need to round up, you're going to use the ceiling function. So for this particular example, we have the ceiling function for 5.2. That's going to round 5.2 up to the next integer, which would be 6. Now if we take a look at the next function down there, we see math.floor, and we see 5.7 on the inside. So just like the ceiling is above you, the floor is always below you. So the floor function is always going to round down. And then from here, because it's always going to round down, this is going to be used anytime maybe you get an answer and you need to know what integer is directly below that particular answer. And in this case, when we round 5.7 down, we get 5. Now this final function here, you're probably noticing, doesn't have the math part of it. This function actually works very similar to floor. It's going to round that number down to an integer. It basically cuts off the decimal part. But this one is actually built into Python without the math library. So here to use int, if maybe you just need to be able to round numbers down and you don't need any of the other functions, you don't need to actually import math for this one. You could just use int parenthesis 3.7, and this one would truncate it and cut off that decimal, and it would become just 3. So on this slide, I've mixed together the normal math functions with the new math functions that we've seen. So I've mixed together things like multiplication and division and modulus with floor and ceiling and power and all of those. So what I need you to do here is I need you to pause the video, go slow, step by step, honestly attempt each of these problems and see if you can predict the mathematical result. When you're done, you can go ahead and unpause the video and then check your answers. So pause it, give it a chance, and then you can move forward and check your answers. So take a minute here and check your answers. Make sure that you were able to show your work in a step-by-step fashion so that I'd be able to follow your thinking if I saw it. And make sure that you can reach the correct conclusion. If you're struggling with the order of operations or any of these math functions, please ask questions. Please get help and make sure that you completely understand how to utilize math in Python before moving on.